Hi guys, welcome to our channel. This is Science Lectures 256 once again. Thanks for subscribing, and we thank you for all your effort you've put in to be with us on this channel. We are pleased grateful for that. So we are continuing with our series of biostatistics, and today I'm going to be talking about an interesting topic called normal distribution curve. We are going to see a normal distribution curve, a standardized normal distribution curve, and the characteristics of these curves. So I think let's start off and dive into into these curves: normal distribution and standardized normal distribution curve. So in nature, populations in nature behave in a way that things are normally distributed. That is, we have things that are always at the extremes, and we have always things that fall in the majority, where the majority lie. So at the extremes, we can have extremes that are very low and extremes that are very high. So in other words, in nature, we'll assume what we call a normal distribution. So we'll have members that have very low. We can use an example of height. So height, we can have the ones that are dwarfs. We can have plants, peas that are dwarf. Then we can have peas that have a medium height, and peas that are very, I would say, tall, that are very low. So these are the three things I wanted us to look at basically. But plants that are always medium will be many in number. So this is how populations are in general. If we are to introduce this concept I'm talking about. So normal distribution, we are going to see our curves, the curves we have here. So if this is a curve, like curve A, and let's say this is a class, we'll have people who are medium performers in the middle of this curve, M, or medium performers. Then we can have individuals that are performing poorly, poor performers. As well, we have individuals that are the high performers within this very class. So that is how I can briefly tell you about a normal distribution. But before we dive into the characteristics of normal distribution curves, I want us to talk about a concept called skewness. Skew. So as data collectors or researchers, we might have a scenario where data are skewed. A skew can either be a positive skew or a negative skew. So skew is where data is towards one side, towards a given extreme. So it can either be a positive skew or a negative skew. If this is our normal distribution curve, let's imagine this is normal distribution, and for a normal distribution curve where the n is greater than 30, normal distribution, in a normal distribution, we are saying where n is greater than 30, in such a curve the mean is equal to mod and is equal to the median. So we have the mean equaling to mod and equaling to median in a normal distribution where n, a population of n, is greater than 30. So in other words, in this normal distribution curve we are having here, that means along this area where we have the mean, it's the same spot at which we are having the median, and it's the same spot at which we are having the mean, all equal. The mod, all equal. So we are having mean, mod, and median all equal at this spot. Now what happens if our data are skewed? If the data are skewed and they are moving towards the negative direction, skewness towards the negative direction, this is a negative skew. Negative skew. It's a little confusing, but to make it more clear, in a negative skew, the mean, let's imagine this is our mean. The mean is lower than the mod, is lower than actually the median and the mod. So that is what happens in a negative skew. The mean is less than the mod and the median. And you see the curve is tending, the tail is towards the negative side, because now we are in negatives, that's why the median is low. But in a positive skew, now this is a positive skew, we have the tail towards the positive end, and this will be our mean, and this will be our median, and finally we'll have the mode here, the mode. So that is the concept of skewness, just in case you're asked about skew. But in a skew, we have data shifted to only one extreme. We have a lot of values within one extreme. In a normal distribution, this is what we expect. The mean, the median, and mode of a big population of n greater than 30 to be equal. But in a negative skew, we are seeing the mean lower than the median and the mode, as well. In a positive skew, we are seeing the mean greater than the median and the mode. So that is the concept of skewness, basically. But now, the most important thing we need to also consider is, we've talked about all this, but let's put our emphasis on this normal distribution curve. So it has some properties, some basic properties, which you might be tasked to know. So one of the properties is that it's bell-shaped. We are seeing a bell-shaped format. So characteristics of a normal distribution curve is it's bell-shaped. So it's bell-shaped, as we can see there. Then another characteristic of a normal distribution curve is that it is symmetrical around the mean. I mean that the portion this side, what is this side, is equal to what is the other side. So this curve is symmetrical around the mean. Because we say the mean is just there in between. So it's symmetrical about the mean. What is around the mean, what is this side, is what is the other side. Then we say it is bell-shaped. Another characteristic is that it obeys, the curve obeys the 68 to 95 to 90, the 99 to 99 rule. So the curve obeys this rule. We are going to dive deep and understand why do we say 68, 95, and 99 rule. So these are some of the basic characteristics of the curve. It's bell-shaped, it is symmetrical around the mean, it obeys the 68, 95, 99 rule. However, before we have also another characteristic before we leave. We say in this normal distribution curve, the mean is equal to mode and is equal to the median. So that is another characteristic of a normal distribution curve. These are the basic 4 characteristics of a normal distribution curve. But I will briefly talk about this rule as we proceed. Now, how does the curve obey this rule? So in saying that it obeys the rule, I think I'll expound on this as we proceed further. So we are going to also talk about a standardized normal distribution curve. But before I talk about a standardized normal distribution curve, let me first talk about this rule. Let me first give more emphasis about the rule. So we are going to get our normal distribution curve and we dissect it properly. So this is the normal distribution curve. Hopefully it's coming out well. So this is the normal distribution curve we're having, but we said our mean is just there. So let's imagine we are using a mean which is a population mean. So we said earlier on in our initial videos that the population mean is denoted by mu. And we said that whenever data are spread from the mean, we get data can be spread by the mean, and we define that by a concept of standard deviation. But we say standard deviation of a population is denoted by sigma. So this curve is divided into, so the more we spread from the mean, actually we are having, this will be a mu plus 1 standard deviation from the mean. Then as we extend also, we'll have a mu plus 2 standard deviations from the mean. Then somewhere around here, we'll have a mu plus 3 standard deviations from the mean. But we say the curve is symmetrical. So what is this side will be the other side, but negative. So we had a mu, it's the central point of our data. So the next point will be mu minus sigma, or the standard deviation. Then the other one will be mu minus 2 sigma. Then the other will be mu minus 3 sigma. So this is what we are having currently on the curve. So I want us to get it from the basics of how this happens, of why we give the curve. But the curve as a rule will have 3 main divisions. So we said, now we first leave alone this. I want to use the same curve just here and try to simplify things. Then we are having, this is our mu. Just let's imagine this is our mean. Let me just call it mean. So this curve can be spread into only 3 standard deviations. And one standard deviation is around here, another one around there, and another one around there. That means here, here, and there. So the first bit of where we spread, we pick, of where we separate the curve as one standard deviation is a 68. This division is 68% of the curve. Then the other portion where we divide this curve is 95% of the curve, whole sum of that. Then the last bit of where we divide the curve will be 99%. So this is where the rule basically comes from. 68, the 99, then the 95%. But we'll get used to this as we proceed with our further calculations. So why did I bring in this concept of the mu and the mu minus? I hope we are together here. So because here I want us to derive something. So this is the mu, which is the mean. But as we spread from the mean, we get what we call standard deviation. So the first one will be mu plus sigma, which is the first standard deviation, mu plus 2 standard deviation, mu plus 3 standard deviation. Curve can only be separated into 3 standard deviations, giving us the 68, 95, 99% rule, like we've seen. So we are going to, there is something called standardizing a normal distribution curve. So this, we've seen a normal distribution curve, but we want to standardize the curve. Standardizing the curve, the normal distribution curve, to become a standardized normal distribution curve. So we want to standardize the curve, and why do we standardize? We want to change the axis. We want to change it from the x to the z, or what some people call z, from the x to the z, the lower line. So imagine this was the x-axis initially, and we are plotting. We want to convert this from x to become a z line. So this is simply what we do. We have a formula, like a rule of thumb. A formula that is there for converting to a z is equal to x minus mu over sigma. So x minus mu over sigma is the formula that is used. So we need to have this formula at the back of our minds. Z, to convert to a z scale, is that we get to go to standardize the curve is, we'll get z is equal to x minus mu over the sigma. So briefly, this is what we are going to do. We are going to insert this. We are going to apply this to the data we have there. So we are going to say that z, to change to a z, now we'll start with the mu. We substitute it for x. So it will simply be, if we are dealing with the mean here, we'll say that that will be z is equal to mu. Z is equal to mu minus mu over sigma. So mu minus mu is 0 over sigma, which will give us what? A 0. So we'll insert a 0 there. If we are to redraw this line, the x line, and we draw a z line here. We draw a z line. So where we had a mu, because we've substituted into this formula, where we had a mu, we'll get a 0, because the answer we are getting is a 0 on the z scale. So that is the 0 we'll get here. Then we'll still do for the same for other standard deviations, and we obtain the value of the z-scale. So we can still do this where we had a mu plus sigma, we substitute the x with mu plus sigma. So where we have an x, we'll say that z is equal to mu plus sigma minus mu over sigma. So this will be mu minus mu, which is 0, and then will remain with sigma over sigma, which will give us a z value of 1. So we'll put the 1 there on the z scale. So we have a 1, we have a 0, we have a 1. Our mean, which was mu, is now a 0. Then we have a 1 standard deviation. Then we have, when we substitute in this, we'll get 2. I hope you guys are substituting. Then we substitute this value, mu plus 3 sigma. We place it where x is, we'll get a 3. So when we substitute the negative values also, because the curve is asymmetrical, we'll get the opposite values of this, negative 1, negative 2, negative 3. And we've standardized the curve. We've shifted the curve from an x curve to a z curve, and that is what we call standardizing the curve. So what are the properties of a standardized normal distribution curve? That is where the interest is now. So properties of standardized normal distribution curve, because the other ones were properties of a normal distribution curve. But now we are saying standardized normal distribution curve. So what happened when we standardize this curve? The curve still, interestingly enough, remained bell-shaped. We remain bell-shaped. The curve is bell-shaped, but the curve will still remain symmetrical around the mean. So the curve is still symmetrical around the mean, then the curve will still obey the rule. The curve will obeys the 68 to 95 to 99 rule. Then still there are some other new things we are seeing. The mean will be equal to mode and equal to median, but equal to 0, because we've shifted. The mean has become 0, and initially the mean was mu. In the normal distribution, mean is equal to mode, is equal to median, but not equal to 0, as in the standardized normal. So the mean still will remain equal to median and will equal to the mode. But now, interestingly enough, all will be equal to 0. That is in a standardized normal distribution curve. Then we are seeing that the standard deviation, we have 0, then 1, then 2, then 3. So the standard deviation of the standard deviation is 1. In normal distribution curve, SD, or standard deviation, gives us a value of 1. That is how a normal standardized distribution curve is different from a normal distribution curve. But before we wrap up this, there is something we also need to consider about this rule. Something important about the rule we need to cover. So we are saying that if this is normal distribution, if that is normal distribution, and we have the rule, let's say we are having a 0, and we have the rule working. Okay, let's use mu. We have the mu, but we have the rule working, and the rule says somewhere there we need a standard deviation, somewhere there, and also somewhere here. So we are saying the first standard deviation is giving us a curve there. Then and the second one, we dissect it from the second line. And the third one, we also dissect it from the third line. Those are SDs. And we say the first one is within a range of 68%. Then another one is within 95%. And the last one is within 99%. So what the rule means, if we are to explain the rule further, that means that the 68% means that the 68 means 68% of the objects lie within, these ones lie within the mean, the mu plus 1 standard deviation. In fact, plus or minus 1 SD. Because what is done this side, on the positive side, where we have a 1, here we have a 2, here we have a 3. Now this means we are having mu plus 1 SD. Actually, we can make it mu. It can appear as mu plus 1 SD, mu plus 2 SD, and mu plus 3 SD. The other side, it will be the opposite. Mu minus 1 SD, mu minus 2 SD, and mu minus 3 SD. So we are saying that 68% objects in the 68 lie within the mu plus or minus 1 standard deviation. Now, if we are to look at the 95%, that means 95, if we are to look at the 95, that means 95% objects lie within the mean plus or minus 2 standard deviations. So it will lie within mu plus or minus 2 standard deviations. Then finally, the 99% objects, the 99 lie within the mu plus or minus 3 standard deviation. In other words, this curve is being divided into 3 major standard deviations as we are seeing. So that is the difference between the standardized normal distribution curve and the normal distribution curve. We've also seen skewness and how it happens, and what happens with the mean in skewness, both negative and positive skew. And this concept is very important for us to understand, and it largely defines what standard deviation means. Thank you for being with us. And